Yes, very good afternoon. Wonderful afternoon we are going to have, right? So, in this particular video, we will discuss about transducers only. And as the students told me, this is very, very required. So I said, okay, fine. And in this video, we will discuss transducer as a element for the projects because most of the 90% of the students, even more than 90% of the students, I guess, in many universities, also in many colleges, in many companies, also looking for a project. And whether it's CSC, whether it's any other branch, they require to make a project. And when they are going to make a project, see, believe me, there is a thing that they need to understand about the transducers. Without transducers, whether they're active, whether they're passive, whether they're inverse, it's very difficult. So we are going to use, so we are going to make, we're going to understand the operation principle, the types of transducers. So this video is totally dedicated to the transducers only. And we will learn about the different type of transducers, their function, their working, how they can be used. Okay, and I will use the transducer which are right now available. Okay, I'm not going to discuss the absolute transducer. So keep in touch in this video for the transducer. So let's start about the transducer now. And we will deal in detail about the transducer. We will talk about many components in transducer, how they're going to use in projects, how they are going to use in different areas. Okay, irrespective of their classification, irrespective of their components. So we are going to discuss in detail about the transducers. So your Dr. Kamal Kar Sharma, your guide, your mentor, your teacher. Let's start with transducer. So what is transducer is all about? Transducer is, first of all, don't confuse yourself. It is going to convert your non-electrical quantity to electrical quantity, and sometimes electrical quantity to non-electrical quantity also. So they are transducer inverse transducer, vice versa. So first we are going to discuss the main transducer that we are going to have. That is your, we will see the characteristics of transducer, basic requirement, classification of transducer. So transducer is a device that I already discussed that converts one type of energy to another, and you are giving non-electrical signal, and it is going to convert into electrical signal. It can be the input signal can be mechanical, can be electromagnetic, can be photonic, can be photovoltaic. There's a difference between photovoltaic and photonic. Photonic deals with sometimes they also deal with quad computing. They also deal with grid computing. They also deals with discrete computing. Okay, so they also deal with qubit, but photovoltaic is related with the sunlight. So photovoltaic and photonic, electromagnetic, electromechanical. Transducer is basically it's different from sensor. Sensor only sense, okay, and it's not going to convert anything like ultrasonic sensor, like piezoelectric sensor. So their sensor, they will sense a certain wide range of signals, but transducer is basically sensor. Yes, it can be input device. Then we require some amplifier or a controller, and then the output. Characteristics of transducer, they are we can say eight characteristics we are having in a transducer: ruggedness, linearity, repeatability, accuracy, and high stability, definitely reliability and high stability, and speed of response. The speed of response should be very, very high. Then sensitivity in the small size. So I'm going to discuss in detail about these requirements of a transducer. Ruggedness, that means it should be able to withstand overload. Linearity in input-output character should be linear. Repeatability, it should reproduce some output signal, then some input signal is again under some environmental condition. High output signal quality, the quality should be high reliability. It should not be damaged under some circumstances. Good dynamic response should be faithful in the terms whenever the output we require it should be obtained to us. No hysteresis, that means the measurement should be accurate, and no intervention of some kind of material, especially magnetic material. No deformation should be there. Classification, we classify the transducer on various parameters: primary, secondary, active, passive, analog, digital, and transducer inverse transducer. Primary, secondary, you know very well, in which there is no conversion. There is no conversion from one form to another form. That is primary. Secondary, in which like LVDT is a secondary transducer. Active, which they have their own source, own content, that is active, which is dependent upon something, that is passive. Then analog, digital. Analog is continuous, digital, which is deal with 0, 1. Then transducer inverse transducer. So primary transducer, the example is board and tube, as I told you, directly sense and convert it. Secondary, first is sensed by something, then output is basically dependent upon some conversion. So that is secondary. That is example is LVDT. LVDTs we'll study in this video about LVDT is very very important, and you have to understand this. It is not absolute, but yes, it is a very old transducer, but still we are using it. So LVDT is a linear variable differential transducer, or linear variable displacement transducer, or linear variable differential transformer. Right, so it's a secondary transducer. Active and passive transducer, which is directly converting, so no extra power is required. It is piezoelectric. Passive is resistive, inductive, and capacitive transducer. Analog transducers convert input quantity like a strain gauge. Remember this, strain gauge and thermocouple are your analog transducers, right? When we talk about digital transducer, they are your converters. They can be your bidirectional converter, unidirectional converters, but when I talk about analog transducer, there's strain gauge and thermocouple. Classification again, inverse transducer, which converts electrical to non-electrical, like piezoelectric. So piezoelectric comes under both, right? The active transducer come under both uh, inverse transducer and transducer. So where we find the application, we can use in like in your what I can say in movie halls, in your when we are dealing with pressures, when we are dealing with some kind of speaker, when we need to convert any signals, acoustics, we use this kind of transducer. What we studied different type of transducers, and along with them, their conversion principle, right? So this question can be asked. You can note it down. Active and passive transducer, how they are different from other transducers. So that we discussed. So now we are going to study, after this, we are going to study different strain gauge, right? Study about the capacitive, resistive, inductive, and capacitive transducer. So they are passive transducer, you know very well. They're not active transducer. Active transducer is only piezoelectric. That we will study also. But now we have to deal with resistive, active, and passive, resistive, active, inductive transducers now, right? Let's start. So now in this we are going to study about the capacitive transducer, then inductive transducer, as I already told you, and with their LVDT also, because LVDT is inductive transducer, very very important transducer. So you can see capacitive transducer. It is used for displacement, pressure, and other physical quantities. So we can use also piezoelectric also. So we need to just put a pressure from the both ends, and two different plates are there and dielectric in between. So it's a passive transducer which require external power for their operation. So capacitive transducer work on the principle of variable capacitance, right? Different capacitances are there and separated by a dielectric. So it can be either air, some medium is required, right? Then how it will work? You can see that the top plate is there, and the inner plate is there. That in between dielectric is there. W, D is the depth. So these L is the length, W is the width. So depending on this, we deal with the capacitive transducer. In the capacitive transducer, we can easily go with the variables like linear displacement, angular displacement, pressure, level of the liquid, and it deals with the Xe only. That is capacitive reactance, right? The application we can use it is first of all, it is very sensitive because it is totally medium dependent, but we normally use for very small distance, right? And in some other cases, the pressure transducer also, where the dielectric constant is going to change with the pressure. Now let's go through inductive transducer. In inductive transducer, we know very well that inductive transducer is basically just we are going to understand the rate of change of current. So when we are going to understand the rate of change of current, V is equal to LdI by dt, that we studied in the AC and DC circuits video. The link is given in the description. So L is the inductance, V is the voltage, right? So we are dealing with flux and the area also. So armature movement would be there, but it would be excited, and the di by dt is very very responsible for this. So inductive transducer basically work on three principles. One is your self-inductance, mutual, and eddy current. And over here, I want to mention over here, the LVDT is basically eddy current based transducer, right? So self-inductance we know very well. It deals with the reluctance and deals with the rate of change of current, right? Mutual inductance, when we're talking about two different coils, they can be neighboring coils, or they can be adjacent coils. This is eddy current production. Whenever the best example is LVDT, so linear variable differential transformer, linear variable displacement transducer. So whenever the conducting field is located near to the coil, Okay, right. We will take a movement from one to first coil to another coil, and this movement will generate the induced EMF. Again, the principle is Faraday law. Whenever the current carrying conductor plays a varying magnetic field, the EMF is induced. Okay. So we will use this transducer in the proximity, in touchpad, in positions, in conveyor belts. These are the application of transducer. So we are going with the last one, linear variable differential transformer, linear variable displacement transducer. In this, you can see that this is equal and this is basically triangular movement. We are having a primary and secondary. A movable core is placed in between, and we are giving an AC source. Right, so series opposite connections are there in this LVDT, and we are going to calculate the displacement and work on the transformer principle. So linear variable differential transformer, three solenoids, center coil is primary and other also secondary. So it is going to move from one end to another end, and depending upon this, E1 sometimes more than E2, sometimes E2 is more than E1 whenever the coil is moving from left to right, right to left. So as a core moves, the primary linkage to the screw secondary coil changes and cause the induced voltage to change. So they are connected. So output voltage different with the top secondary and the bottom secondary voltage. So this will be created and we can easily calculate with the help of displacement, we can generate a voltage. So this is the best example. You can go over there, you can check out this primary and secondary color placed over there. So I take from the RDP group. So you can say voltage wave LVDT are shown over there. Working of LVDT again, I take it from our core displacement. This kind of graph we obtain in the case of core displacement from positive to negative, negative to positive. Right? Whenever the core is a central position, there will be no EMF induced, but whenever it is towards left, then E1 would be more than E2, it is a positive, and if E2 is more than E1, it would be negative. So error and adjustments, we normally go with core is slowly longitudinally to the LVDT. First of all, that is very, very important to reduce eddy current losses. Otherwise, if it is not placed in a longitude way, so we will have a problem, right? And we also have to provide shielding for the electrostatic electromagnetic. If we use this LVDT, we use as a main transducer, dislocation of electrical signals for pressure, force, and we also use a servo mechanism that we studied in the DC machine video. You can check it out. Already the link is given for the machine video. So where we can use it, we use it for the electrical isolation, sensitivity, linear characteristics. So these are some disadvantages also affected by the vibration, dynamic response is limited mechanically, and with the frequency of excitation voltage. That we studied today. We studied about the inductive capacity and resistive transducer. We also studied about LVDT, that's working and principal operation. Thank you. So now we are going with the strain gauge and thermistors, right? So any comments you have, any kind of query you have, you can write in the comment section. Now we are going to deal with the piezoelectric and thermocouple. These are very, very important transducers and normally used whenever you're dealing with load cells, whenever you're going with temperature change. So when I'm dealing with thermocouple, the three effects are very important over here. One is Peltier effect, one is Seebeck effect, and one is Thomson effect. And we normally used the Peltier effect. And these kind of effects also use MHD also, magnetohydrodynamic generator, then we make MHD generator. So these effects are very, very important. And we are going with the piezoelectric and thermocouple, right? So let's start. So we will go with thermocouple. What thermocouple is all about? We will go with the application working principle of thermocouple, how the thermocouple works. Then we will go with the application of thermocouple, piezoelectric transducers, and application of piezoelectric transducer. So we know very well, as I told you, we have the effect, Seebeck, Peltier, and Thomson effect. So basically, thermocouple is a combination of two junctions, right? And the two junctions, that means we are making two junctions available. One is at a cold junction and one is at a hot junction. And when this hot and cold junction are connected together, so we know that the current will flow because these temperatures are nothing but working as a potential. One is heat source, one is not a heat source, and we will develop a heat source. Is very, very good example, a good figure. You can see that, and you can easily calculate that the current will flow. And so thermocouple is a temperature measuring device having dissimilar metals. So it produces a voltage whenever the temperature is different at the two parts of the circuit. Three effects: Seebeck, Peltier, Thomson. Seebeck effect is basically conversion of thermal energy converting to electrical directly, but it deals with only thermal difference, influence of thermal difference. Whereas Peltier says it's a just opposite. It states the difference of temperature can be formed among any two dissimilar conductors by applying potential variation among them. Right? So it says difference of temperature can be, it is just opposite to feedback. Feedback says that if there is a temperature difference, the voltage can be there, potential variation can be seen. He said if you are going to apply potential variation, the temperature difference can be seen. Third one is Thomson. It states dissipate metals. That means different materials. If two joints are there and we are going towards a gradient of temperature, then that the direction of temperature can be measured or can be seen. This effect states that if two separate metals fix together and they form two joints, then the voltage induced the total conductor length due to the gradient of the temperature. This gradient word is very, very important. Anything divided by length is nothing but gradient, right? Thermocouple schematic diagram, we know very well two different materials I already showed you. The T1 and T2 are being connected over there, and we can see one is measuring temperature, one is known temperature, and we can easily calculate it. This is the working of thermocouple, right? If the two different potentials has been provided to different nets. Where we can use a thermocouple, using thermostats in offices, homes, cryogenic, low temperature application, and they are used in gas machines also reacting the pilot frame. Now, last one is piezoelectric. So piezoelectric transducer, as we already know it, that piezoelectric transducer is basically we are having a base, right? And we are having a pressure port. We are going to place the crystal. So piezoelectric transducer work on the principle of piezoelectric effect. This means whenever the pressure is applied, they produce electric voltage. That can be easily measured by any kind of equipment, and but they detect motion at a higher low frequency. So EMF developed due to the displacement of the charges. So this effect is changeable. When the potential applies, then we can deform and form. This effect is also known as piezoelectric effect. Both effects are possible if you are putting a pressure and then the voltage is induced or EMF is developed, or you are putting a variable potential difference is placed, then you can deform or form the material. So pressure is applied to the crystal with the help of four summing devices, and deformation induces the EMF, which determines the value of applied pressure. Principle of operation: transducer operating environment, the acoustic properties of medium, air, water, or ice. So energy conversion mechanism, whenever the externally applied electric field applies a change in the dielectric polarization. Over polarization is very, very important. Polarization is nothing but just production of charges at the two different places, as the dielectric polarization is talking about. And we are going to the generating action takes place when elastic strain causes change in polarization, right? So this is very, very important. So transducer must withstand the severe effects of sea, water, biological, any kind of environment where it is placed. So where we are principle of application, linearity, reversibility, and passivity, and the conversion criteria. Application piezoelectric transducer, we use in sonars, we use in microphones, speakers, and electric lighter also. That we studied what transducer is, what the thermocouple, how can we use thermocouple, how can on which effects, on which principle this thermocouple is based, how the piezoelectric effect take place in the system, right? Now we will talk about different other transducers. This we are going to study now. In this we are going to study the two different transducer, that is strain gauge and thermistors. Very, very important again, right? So we will study about the strain gauge and thermistors over here. Let's start. So strain gauge and thermistors are basically, as the name suggests, they are related with pressure first of all, and basically to broaden or to shorten or not to deform, right? And thermocouple thermistor is basically deal with the thermal resistivity or thermal properties of a material. So if a strip of the conducting material, we know that if the strip of the conducting metal is placed under compressive force, see, without deforming, so it will broaden. So that means we are talking about elastic limit of a particular material or a metal strip. So, but we are going to use over a metal strip. So this strip can be used as a measuring element for physical forces, and we can easily get changed with the help of changing resistance. So this is strain gauge. Right? That is the principle of strain gauge. So you can see tension resistance increase and compression resistance decreases. So we will go with that, and it's basically a resistor. It's a metal strip. So metal basically used to measure strain. So whenever the external force is applied, the deformation occurs, and whenever the deformation occurs, is both compressive as or it can be measured by the strain gauge. Working the functioning strain gauge depends on the electrical resistivity. First of all, that is very important. Note it down. When the object stretched, okay, but within the elastic limit, it should not break. It should not deform. Okay, so decrease electrical resistance. And electrical resistance, understand the amount of stress induced. So you can see R is equal to L by A, where R resistance and length is a cross-sectional area. We have a gauge factor, delta R by Rg, where delta R is the resistance, change in resistance due to strain, and Rg is the resistance of the undeformed gauge. You can see a specimen, strain gauge 1, strain gauge 2. So it is also when with no force, it is balanced. With a force, it will bend downwards, and actually it will put a compressing gauge at the same time. So we are having strain gauge based on the mounting and based on the working. It can be mechanical, it can be electrical, and piezoelectric, and bounded and unbounded also. Mechanical, we know it is two plastic layers, right? Top layer and bottom layer. One layer is glued, another is not. Different kind of formation can be done, right? Piezoelectric, when the strain is applied overhead, and strain can be calculated from the voltage. Mechanical, this is mechanical strain gauge. This is electrical strain gauge. Normally we use it when the electrical wire is stretched with the limits of the elasticity. Okay, so it does not break, it does not deform. So strain can be inferred by the measuring change in the resistance. Advantage and disadvantage of strain gauge. See, it is non-linear. That is a disadvantage. And but anyhow, there is no moving part, so it is not expensive also. We can go with torque measurement, bending and deflection measurement, strain measurement. Mister, second last transducer we have. Thermistor basically work on the principle the resistance of some material change with a change in temperature. So we are going to use semiconductor over here, and when the temperature changes, its resistance change, and similarly, we can easily measure and calibrate against the input quantity, right? So you can see thermistor symbol. It is very simple. Okay, so it falls on temperature rise, negative temperature coefficient. So normally we use semiconductor for the same application. Go with the temperature compensation. Go with the measurement of gas composition, current limiting devices for the circuit protection. We can go with the fuses also. That we studied that how we can use thermistors. What is the principle of thermistor? Thermistor nowadays are used in many cases. It is used in gas chimneys. It is used in various components where we can have, because semiconductor is basically insulator at room temperature. So we can use semiconductor at various devices at various positions. Wherever we can use this thermistor for protection also. So many applications can be formed. Now the last topic we are going to complete now. They are different transducers, but they are triaxial sensors. They are used in drones. They are used in GP that use Google, just finding in Google Images, right? They are also used in Google Maps. They are also used in automated vehicles. So these are the last topic that we are going to discuss is photoelectric and triaxial transducers. So they are very important. Nowadays, most of the students are working on this. So let's go with photoelectric and triaxial transducer. So we will go with very little bit content that we will go with a photovoltaic cell, and we will go with a photoelectric transducer, photoemissive cell, and their applications. So photoelectric transducer, as we know very well, whenever the radiation will fall, we will use semiconductor. So whenever the photosensitive element, sometimes we are using LDR also, light detecting resistor. So photosensitive element, so electric current would be generated. And photoelectrified is just the ejection of the electrons from a metal, right? So whenever illuminated by a light or any radiation of suitable wavelength, right? Similarly, when we talk about working on the photoelectric transducer, it basically absorbs the light energy, right? And hence the electrons start moving. So three effects that can be produced: resistance will change, the output current will change, and the output voltage will change. So there are different types of photoelectric transducer. First is photoemissive cell. So it converts photons into electrical energy, incident light. I hope you remember that we discussed about the mu is equal to sine I upon sine R. There is one formula in the plus one and plus two. Okay, regarding the refractive index. So anode and cathodes are coated with a photoemissive material that can be antimony, that can be cadmium, that can be anything. So we require a material of a photoemissive properties, and whenever the photons, when the light, incident light is falling on it, then we are having a cathode and emitter, and then the deflection can be seen as a deflection meter. So photovoltaic is just the active transducer because it is just converting light energy into your what I can say, converted to electricity. So you can see the photovoltaic cell is a type of active transducer. So current start flowing it. Silicon and selenium we are normally used. Silicon is very not very that much costly and normally used in abundant in Earth. And when a semiconductor material observes it, the free electrons start flowing. It is just the depletion layer movement as it is lies between the p and n junction, and going to change with the forward biasing and reverse biasing. In forward biasing, the depth of depletion layer decreases. In reverse biasing, it increases. We are having the advantages of photovoltaic cell, robust in construction, need no external power supply, and photocurrent stronger than the photoemissive cells, produce more. Disadvantage we have photovoltaic cell. It has low internal resistance, so amplification is difficult. Yes, some of the disadvantages we have. It is costly also. So it consists of cathode and anode. I already discussed different material is required for disadvantage of photoemissive cells. Photoconductive cells we have, it is basically known as LDRs, as I already discussed with you, a light dependent resistor. So photoconductive cells. Okay, so work on the principle that the resistance will change with the help of incident light and it start conducting, right? But they are very sluggish. They show very less effect. Last topic we are talking about now, triaxial sensors. These topics, this is very important, triaxial sensors, in which we will talk about accelerometer, gyroscope, and magnetometer. So accelerometer are basically measure acceleration, as the name suggests. So if they convert electrical quantity into acceleration, so they are inverse transducer, first of all. Second is gyroscope. As the name suggests, gyroscope, it measures angular velocity. So when I'm talking about angular velocity, they are basically capacitive transducer, right? And they are taking care of inductive and capacitive reactance. Magnetometer is basically used to measure magnetic field. So when I'm saying magnetic field, we have to understand that we have to, because might you remember that we are having a permanent magnets and draw the magnetic field around certain material, right? So we are using magnetomaterial. Triaxial sensors, we normally used highly sensitive accelerometers for your Google Maps, monitor vibrations. Might you see we are having vibratometer, we can easily check out there is some vibration or not. This will help us to protect ourselves from machinery, right? In digital cameras, we normally used for flight stabilization, as earlier discussed, in drones, and detect the position of device in laptops and mobiles. So these are triaxial sensors, very important applications. So these are the questions that can be asked in any of the paper or in an interview, that from my submission. Other question can also be asked. So different type of photoelectric transducers, how the photoemissive cells will work, how the triaxial sensor, what are the triaxial sensors, how they will work. So these are certain questions that can be asked. So this is all from my side for a transducer. We are done with transducer. What we studied what transducer is all about, what is the principle, how they're classified, what are the types, how they will work, how they can be submissive. So this that we studied. Okay. So any kind of doubt you have, you can write in the comment section, right? Happy learning and have a happy day. Thank you very much.